Hi everybody, in this video we're going to talk about the parts of a circle, starting with the radius. The radius of a circle is a straight line from the center of the circle to any point on its exterior. So here we have a circle, right? And this line over here would be a radius of the circle because you can see it's going from the center to the exterior of the circle in a straight line. And a radius does not have to be horizontal like this. So for example, this would also be a radius. It could be diagonal. It could be vertical like that. That would also be a radius. The important thing is that it's going from the center to the exterior in a straight line. Something like this would not be a radius because even though it is going from the center to the exterior, it is not a straight line. Okay, so that's radius. And the next thing we're going to talk about is the diameter. So the diameter of a circle is a straight line connecting 2 points on the exterior of the circle and going through the center. So you can see that this right over here is a diameter of this circle. It is connecting 2 points, 1, 2, on the exterior of the circle and also passing through the center of the circle. Now if we were to do it vertically, that would also be a diameter. That's fine. Or diagonally, that's fine as well, as long as it's a straight line going through the center, okay, and connecting 2 points of the exterior. Something like this would not be a diameter because it is not a straight line, even though it is going through the center and it's connecting 2 points on the exterior. Something like this would also not be a diameter, even though, well, I tried to make it a straight line. So even though this is a straight line and it is connecting 2 points on the exterior, it is not a diameter because it is not going through the center of the circle. So this right over here would be called a chord. And the next one we're going to talk about, probably guessed from over here, circumference. So the circumference of a circle is the exterior of the circle. Okay, so pretty simple. It's this part of the circle. You might say it's the circle itself. Okay, all right, so that's circumference. And then finally, the area of a circle is the amount of space inside it. Let me make this a little bit bigger here. So if we're talking about the space inside the circle, right, then that's the area of the circle, right? Specifically, we're talking about how many square units could fit inside of the circle. Just like if we're measuring the area of a rectangle, then we want to know how many square units can fit inside the rectangle, and we would do that by doing the length times the width. And in another video, we'll talk about how to find the area of a circle. But for right now, just know that the area of a circle, just like the area of a rectangle or a triangle or anything else, just refers to the amount of space that's inside that circle. All right, so next up, let's I want to move on to talking about if the radius is one-dimensional, two-dimensional, three-dimensional. And before I do that, let's talk about what I mean by dimensionality. So let me scroll down here. Okay, so one-dimensional objects have length, but no width or height. So for example, these two objects over here would be one-dimensional. They have length. You can see this line over here. It has a length, but it doesn't have any width and it doesn't have any height. Okay, so it's just one-dimensional. The only dimension it has is length. Okay, now something like this is also one-dimensional, and you might be thinking to yourself, well, wait a minute, isn't this really two-dimensional, because it seems to have a length going from here to here and also a width from here to here, so wouldn't we consider this two-dimensional? Well, no, it's still one-dimensional. It might be sort of wriggling around in two-dimensional space, but the object itself is one-dimensional. So if I were to imagine that this thing were like a thread and it's all wriggly like this. If I were to just pull on the ends of it, then I could get it looking like this one over here. So even though it is in two-dimensional space, and that's why it can wriggle around a little bit, it is itself still just a one-dimensional object. Just pull on the ends and then you can see it's just like this line over here. Okay, now moving on. Two-dimensional objects have length and height, but no width. Okay, so over here we have an example. Here's a simple rectangle, right? It has a length and a height, but it doesn't have any width. Okay, there's no third dimension there. And something like this, which maybe I didn't draw it very well, but I mean that to be like a piece of paper over here, which is sort of somebody waved it like that. This would also be two-dimensional. And you might be thinking to yourself, well, wait a minute, shouldn't that be three-dimensional? Because I can sort of see a length and a height and also a width going this way, right? Well, just very similar to how this was a one-dimensional object in two-dimensional space, this over here is still a two-dimensional object, even though it is waving around in three-dimensional space. Okay, the object itself, this piece of paper, is still just two-dimensional. If I wanted to, I could pull it out like this and just flatten it out, and then it would look just like this rectangle over here. Okay, so it is still two-dimensional. And before I move on to three-dimensional, you might be asking yourself, well, couldn't you say, instead of saying that this has a length and a height and no width, couldn't you call this the width? And couldn't you say that this has a length and a width, but maybe no height? Or could you call this the height and this the width, and say that this has a height and a width, but it doesn't have any length? Yes, you could say that. It really doesn't matter what name you ascribe to each dimension. The point is, this rectangle is sticking out. It's you could say it's sticking out in two directions rather than three, and that's why we call it two-dimensional, right? Regardless of whether you want to say it has length and width but no height, or length and height but no width, or whatever you want to say. It's just two of them, not three. Okay, and then finally moving on to three dimensions. So three-dimensional objects have length, width, and height. You can see over here, this is called a rectangular prism, because the base would be a rectangle. So it has a length, it has a width, and it also has a height. So this, and this, by the way, like a Pepsi can or a Coca-Cola can, this is called a cylinder. It's also three-dimensional. It's got length, width, and height. Okay, so one-dimensional, two-dimensional, three-dimensional. So that was sort of, that was a little bit of a tangent. And now let's get back to circles over here. So a radius is a one-dimensional object. Remember, the radius is a straight line from the center of a circle to any point on its exterior. And another way that I like to talk about one-dimensional objects is sort of informally, I'll say that a one-dimensional object is something that can be measured with a ruler. So if I wanted to just measure the length of this radius with a ruler, I could do that, no problem. I could take this ruler over here, I could put it up to the radius of the circle, and then I could measure it, okay? So a radius is one-dimensional. A diameter is also one-dimensional. So just like the radius, if I wanted to measure the diameter with a ruler, hey, no problem. Just take the ruler, put it up to the diameter, and measure it, okay? Easy. All right, so so things which are one-dimensional can be measured with a ruler, okay, just very simply. Moving on to the circumference. Circumference is also a one-dimensional object, and that might sound a little bit strange. You might be asking to yourself, well, wait a minute, how can I take a ruler and put that up against the circumference of the circle and measure how long it is? It doesn't seem like I could really do that with a ruler, but you could if maybe you had another tool. If you had, let me get my string back here. To measure the circumference of a circle, you could wrap a string around it and then lay the string out along a ruler. So if we had a circle in front of us, then what we could do is we could, let's say, so pretend that I have some circle in front of me and I don't want to measure the circumference of that circle. I could take my string, I could wrap it around the circle, okay, and once I get it wrapped around, then I could maybe take my scissors over here and just cut that off like that. And then I would just take my ruler and stretch that out. I hope you can understand what I'm doing here, right? Just take this and stretch it out against my ruler and just measure it. So maybe I would want a longer ruler, or maybe two rulers next to each other to measure this, but hopefully you get the idea. It is possible for me to, in the end, take the length of that string, which is the length of the circumference, and measure it with a ruler. So a circumference is also one-dimensional. Just like I asked you before to imagine taking the ends of this wiggly line over here and stretching it out like that to make a straight line, we could do something similar with the circumference of a circle in order to measure it. All right, and so moving on, area. This is the only part of a circle that we're talking about which is not one-dimensional. So area is two-dimensional, and that's not just circles. So the area of a rectangle, or the area of a triangle, area is always two-dimensional. So we cannot measure area with a ruler, right? Even if I took my string and I tried to do some sort of trick with the string like I did for the circumference, there wouldn't be anything that we could do to measure the area like that. Okay, so area is measured in two-dimensional square units, right? Square centimeters, square inches, square miles, and so on. So that literally means when we talk about square units, measuring something in square units, we literally mean how many little squares would fit inside the object. Okay, so if the square, let's say that each of these squares over here had a length of 1 centimeter and a height or width, whatever you want to call it, of 1 centimeter, then we would say that each of these squares is 1 square centimeter. The length is 1 centimeter, the height is 1 centimeter, the square itself is 1 square centimeter. And then we would just ask ourselves, well, how many square centimeters can fit inside of the circle? And you can see that this one would be approximately 4 square centimeters, okay? So we would not be able to measure the area of a circle or anything else directly with a ruler. If we wanted to measure the area directly, then we would have to use some sort of a square grid like this. Now, there is a way to figure out what the area is using the radius of a circle, actually, but that is for another video. I'm going to save that for later. Okay, so that is it, and have a great day.